Okay, today we're doing Module 3, Lesson 3, and this is the last lesson before your weekly check-in, which will be tomorrow, okay? So let's take a look at our learning goal. Let's first understand what our learning goal means so we know what we're preparing to do today. Today's learning goal says, I can use rectangular fraction models to add fractions with unlike denominators. Okay, think about what we did yesterday. Did we add fractions yesterday? Yeah. So that part's the same. So just like yesterday, we're going to be adding fractions. But what's the difference? Yesterday, we added fractions with like denominators. What did like denominators mean? Same denominators. But today, we're doing it with unlike denominators. So will the denominators be the same today? No. No. Also, yesterday, what model did we use to help us out?
Number lines.
Number lines, right? Does it say we're using number lines today?
No.
Today we're using rectangular fraction models. And some of you might be thinking, wait, what? Rectangular fraction models? What's that? I have good news for you. Let's break down this word. Rectangular. That means what shape is it?
Rectangular.
Okay. And fractions. That means it's showing what? Fractions. So let me show you. This is an example of a rectangular fraction model. What fraction is that showing? 1/4. This is also still a rectangular fraction model. What is it showing now? 2/8. Have we used models like this before?
Yeah.
What did we call them before? Area models. Instead of calling them area models, from now on, we are going to be calling them rectangular fraction models because they are rectangular in shape and they show fractions. Make sense? So today is all going to be about drawing rectangular fraction models to help us add fractions that have denominators or bottom numbers that are not the same. Got it? Now, yesterday I was talking about how if Arav has 2/3 and Young has 2/3, how many thirds do they have altogether? 4/3. Or if Emily has 1/6 and Grishma has 1/6 and Helmi has 3/6, how much 6 do they have altogether?
5.
1 plus 1 plus 3, which is 5. And the unit is 6. But if Emily had 1/3 and Grishma had 1/2, could we do 1 plus 1 is 2 and then put them together? Because they have different things. Emily has thirds and Grishma has halves. Can I add different things together like that? No, those have different units. What's the unit of what Emily has? Thirds. What's the unit of what Grishma has? Halves. Are those the same thing? No. Okay. That's what's going on here. We have 1/4 and 1/3. Are those the same size pieces? Like, if you had 1/4 of a piece of cake and Rohan had 1/3 of a piece of cake, would you be willing to trade pieces?
Well, if you were Rohan, no.
Well, maybe yes, if you're trading up. But if you were me, would you be down to trade with Rohan?
Yeah.
If you want less cake, right? They're different size pieces. So the directions tell us to draw a rectangular fraction model. And then in order to do this, okay? So I'm going to show you how we do this. I'm going to model both fractions using rectangular fraction models. By the way, what's another word for rectangular fraction models? Area models. So let's do 1/4 first. Go ahead and draw a rectangle and label the whole thing as 1 unit. Now, in order to show 1/4, I need to divide that 1 unit into how many equal parts? 4. I'm going to shade in one of them and label that as 1/4. Now, right next to it, I'm going to draw another unit and label it as 1. But this time, what's my denominator? 3, so I need to split it into 3 equal parts. I want you to notice that on the left-hand side, I used vertical lines going up and down to split my rectangle. And on the right-hand side, I used horizontal lines going left and right. Make sure you also label the amount that you shade in. If I were to now add some horizontal lines to this 1/4, let's say I divide it like this. Did I change the fraction of the unit that is still colored in? Did I color in more or less? No, it's still 1/4 of the whole entire unit is colored in. Do you agree?
Yeah.
Okay, but this time I've converted it. Now, instead of having 4 total sections, how many total sections did I divide my unit into? 12. Okay. And how many of them are colored in? 3. Did we convert 1/4 to become 3/12?
Yeah.
Are they equivalent?
Yeah.
Yeah, because I didn't change the amount that was colored in. Do you agree?
Yeah.
I just changed the units that I'm expressing that fraction in. Okay. Using numbers, what did I multiply 1/4 by to get 3/12? 3/3. Okay. Now, what if I do the same thing over here? How can I make the 1/3? I want it to have the same denominator as over there. What denominator do I have here? 12s. So I want it to end up with some number of 12s. Well, if I were to go like this, do you see how I'm just drawing the vertical lines over here and drawing the horizontal lines over here? Now how many sections did I divide my entire unit into? 12. And how many of them are colored in? 4. Did I change how much was colored in? It's the same fraction of that whole unit that's colored in. But now, instead of calling it 1/3, I have it called 4/12. Let's prove it. Using numbers, how did I get from 1/3 to 4/12? I multiplied 1/3 by 4/4, which is just a version of 1. Does multiplying by a version of 1 change the value? So does that show you that 1/3 is equivalent to 4/12?
Yeah.
Now, can I rewrite this problem? Instead of calling it 1/4 plus 1/3, I have a new version of 1/4, which is 3/12. And I have a new version of 1/3, which is
4/12.
Now do I have like denominators? My new like denominator is what number?
12.
Now if I have 3/12 and I want to add 4 more 12s, how many do I have altogether?
7.
7/12. So therefore,